Welcome back to our TV repair and installation channel. Today, let's learn about the process to create nuclear energy reactors used in icebreakers. First, let's learn about the RITM-200 nuclear reactor produced by Russia for use in the new generation multi-purpose nuclear icebreaker Arktika. First step, casting blanks, manufacturing shells. The total weight of the billet is up to 547 tons and will be put into the casting furnace at a temperature of 1200 degrees Celsius with a 15,000 TF automatic forging system. Step 2. Machining of the flange holes for the steam generator cassettes. The time to machine the flange holes for the reactor shell is up to 39 hours and 38 machining steps. All these flange machining steps require specially developed tools and processes. Step 3. Create a corrosion-resistant surface. Up to 10 tons of special anti-corrosion tape must be used to cover the reactor shell to protect the metal layer from the corrosive environment. This surface coating process is carried out in 8 months. Step 4. Create circumferential welds. This process requires 4 days of continuous, non-stop work and uses more than 600 kilograms of welding metal wire. Each weld has a thickness of 150 millimeters. Step 5. Welding the nozzles. Heat treatment. The reactor nozzles will continue to be welded. The metal block is heated at a temperature of 200 degrees Celsius. Preheating is necessary to prevent cracks in the weld. This process takes 3 days. Step 6. Close the weld. Each weld is also 150 millimeters thick and requires up to 600 kilograms of welding metal wire to weld them into a finished product. Step 7. Weld the hydraulic chamber. The weight of each hydraulic chamber is 4,500 kilograms, and the thickness is 82 millimeters. Welding the hydraulic chamber is the most difficult and longest job, taking up to 20 days to complete. Last step. Fabrication of in-vessel internals and reactor closure head. The fabrication of ship internals and reactor enclosures is an important aspect of nuclear power reactor construction. These components play an important role in the operation and safety of the reactor. Vessel interior design includes reactor vessel internal structures and components, including core support structures, control rod actuators, instrumentation, and other components that create favorable conditions for reactor operation and control. The reactor closure head is an important part that helps seal the reactor vessel, facilitating access for fueling and maintenance. It typically contains mechanisms to hold the reactor vessel closure flange, control rod actuators, and other safety features. Both the ship's internal components and the reactor closure undergo comprehensive factory testing to ensure they meet safety and performance requirements. This may include functional testing, pressure testing, and other assessments. Once fabricated and tested, the components will be transported to the nuclear reactor assembly site. Throughout the entire manufacturing process, compliance with strict quality and safety standards is critical to ensure the reliable and safe operation of the nuclear power reactor. This is another type of nuclear reactor VVER-1200 used in nuclear power plants. With a weight of 334 tons, a length of 12 meters, a diameter of 4.5 meters, the output reactor cooling water temperature is 328.9 degrees Celsius. Production time 36 months. Production operations 768. Quality control points 315. The VVER-1200 water energetic reactor with a power output of approximately 1,200 megawatts is a type of pressurized water reactor, PWR, that has been developed and used in various nuclear power plants. Its functions and uses are similar to those of other pressurized water reactors, providing electricity through controlled nuclear fission reactions. Here are the main functions and uses of the VVER 1200. Electricity generation. The primary function of the VVER 1200 is to generate electricity through nuclear fission reactions. The heat produced by the fission reactions is used to produce steam, which then drives turbines connected to generators, ultimately generating electrical power, baseload power generation. VVER 1200 reactors are designed for continuous and stable operation, making them suitable for baseload power generation. Baseload power plants provide a constant, reliable output of electricity to meet the minimum demand on the power grid. Large-scale power production. The VVER 1200 is a relatively high-capacity reactor, capable of producing a significant amount of electrical power. This makes it suitable for large-scale power production, contributing to the overall energy needs of a region or country. Grid stability and reliability. Nuclear power plants, including those using VVER 1200 reactors, contribute to grid stability and reliability. Their ability to provide a consistent and continuous power output helps balance the fluctuations in electricity demand. Low greenhouse gas emissions. Nuclear power plants, including those with VVER 1200 reactors, produce electricity without emitting greenhouse gases during operation. This makes them a low-carbon option for electricity generation, contributing to efforts to reduce carbon emissions and combat climate change. Diverse energy mix. The VVER 1200 adds diversity to the energy mix of a country, providing a source of electricity that is not dependent on weather conditions, unlike solar or wind power. This diversity helps enhance energy security and resilience. Long operational life. Nuclear power plants, when properly maintained and operated, can have a long operational life. The VVER 1200 is designed for efficient and safe operation over several decades, contributing to the long-term stability of the energy supply. Technology transfer and collaboration. The VVER 1200 design has been used in various countries, and its construction often involves international collaboration and technology transfer. This promotes cooperation in the field of nuclear energy and contributes to the sharing of knowledge and expertise. Heat generation for industrial processes. Some nuclear power plants, including those with VVER 1200 reactors, can be configured to provide process heat for industrial applications. This dual-use capability enhances the economic viability of nuclear power.